Hello everyone, in this video we'll be solving LeetCode problem number 1, that is to sum. In this question we are given an array and a target number, and we need to find two indices such that the sum of numbers present at those two indices is equal to the given target number. For example, in this case we'll return 0, 1 because 2 plus 7, that is the number present at the 0th and the number present at the first index, add up to the given target number. It's also given that you cannot use the same index twice. For example, in this case, we cannot write 3 plus 3 is equal to 6 because in doing so, we are using the same index twice. That is the 0th index twice. So that is not allowed. However, two different indices can have the same value. For example, in this situation, here we can write 3 plus 3 is equal to 6 because in doing so, we are using the 0th index and the first index, which are not the same. You cannot use the same index twice. If you use a particular index, it will get exhausted. It's also given that your problem will have exactly one solution. That is, the combination of indices that you return will be unique. There will be no other possible combination of indices such that the sum of numbers present at those two indices will be equal to the given target number. So your solution will always be unique. We'll be solving this question using three approaches, and as we progress through the video, we'll be moving from the least efficient or the brute force solution to the optimum solution. So starting off with the brute force approach. So basically what we are going to do here is that we will consider all possible pair of indices, and for each pair we will check whether the sum of numbers at those indices is equal to the given target or not, and when we find such pair we will just return that. So how things will proceed is that the first pointer will initially point to 0, and then we will now traverse the array like something like 0 1 0 2 0 3. We will not take 0 0 because, as mentioned earlier, you cannot use the same index twice. So we'll move 0 1 0 2 0 3 0 4. So after this iteration we would have considered all pairs with one index as 0. Now we will move this pointer one step forward, and then we will consider all possible pairs with one index as 1. So we will move 1 2 1 3. We will not move 1 0 because that pair is already considered in this 0 1 pair, because the combination 0 1 or 1 0 is anyway same because the order does not matter. So for 1 we will move 1 2 1 3 1 4 and so on and so forth. Now let's see how we can write the code for this. So we are using I as a first pointer, and it will move from the beginning to the very end of our array. And we are using j as our second pointer, and it will move from one position to the right of our I pointer, and it will also move to the very end of our array. And now for each possible pair of indices, we will check that if for any particular pair, if the sum of the numbers present at those indices is equal to the given target number or not. And if we find any such pair, we will just return those two indices in the form of an array. So return new integer array, and in the array we will just insert two elements, that is I and j, or j comma I because the order does not matter here. And if we don't find any such pair of indices, then we will simply return an empty array. Return new int array, and it will be empty. So what will be the time complexity of this code? It will basically depend on the number of times this part of our code gets executed, and this will depend on the total number of iterations of this inner loop. So to understand this, consider this example. When the value of I is 0, the inner loop will get executed 3 times. J will move from this position to this position. When the value of I is 1, then the inner loop will get executed 2 times, and so on and so forth. So when the value of n, that is the number of elements, is 4, the inner loop gets executed 3 plus 2 plus 1 times. That is the sum of the first 3 natural numbers. So in case when the number of elements is n, the inner loop will get executed the sum of n minus 1 natural number times, and the sum of n minus 1 natural numbers is equal to the sum of n natural numbers minus n, and the sum of n natural numbers, as we know, is n into n plus 1 by 2. So this inner part will get executed n into n plus 1 by 2 minus n, which is a quadratic expression. So the time complexity will be big O of n squared. So let's move on to the next approach. In this approach as well, we will be considering pairs of indices, but we will not consider all possible pairs. We will consider the pairs of indices based on some systematic logic. So let's see what that logic is. First of all, we will sort the given array and we will consider two pointers, a left pointer which will initially point at the first element and a right pointer which will initially point at the last element of the given array. And then we will sum the numbers present at the left and the right pointers, and we will put that value in a variable called sum. So there are three possible cases. First possible case is that the value of sum becomes equal to the target. So your problem is solved. This is a real number line which I have considered. I have shown the target number using this arrow, and this is the sum that we are currently considering. So if the value of the sum after summing the numbers which are at the left and the right pointers, if that sum is equal to the target, then the problem is solved. The other two cases are that our sum will be less than the target. So our basic job is to change the pointers, to move the pointers in such a way that the sum moves closer to our target. So if the sum is less than the target, we need to increase the sum. So to increase the sum, we need to move the left pointer forward, because as mentioned, this array is sorted in increasing order. So to get a bigger sum, if you move the left pointer one step forward, the left pointer will start pointing at a bigger number, so the sum will increase. So if the sum is less than the target, we will move the left pointer forward, and if the sum is greater than the target, we need to reduce the sum. So to reduce the sum, we will move the right pointer one step backwards, so that now the right pointer will point to a smaller number because this array is sorted. So with each successive iteration, we will move these pointers in such a way that the sum reaches closer and closer to the target. And the basis for this movement will be depending on the relation between sum and target. If sum and target are equal, a problem is solved. If sum is less than the target, we will move the left pointer one step forward to increase the sum because the array is sorted. And if the sum is greater than the target, we will move the right pointer backwards to decrease the sum so that it reaches closer and closer to the target. We need to stop when the left pointer will point at the same index to which the right pointer will point, because it's already mentioned in the question that we cannot use the same index twice. And you might also think that can we move the right pointer further left and the left pointer further right? So the answer is no, because if you move the right pointer further left, it will now start considering values which the left pointer has already considered, and if you move the left pointer further right, it will start considering values which the right pointer has already considered. So it will lead to recomputation and it's of no use. So we will need to stop when the left pointer is equal to the right pointer. The left pointer will only move forward when it moves, and the right pointer can only move backward when it moves. Why is that? Because some people might think this way, that suppose initially the sum is less than target, you added these two numbers, you got a sum which was less than your target. So you incremented the left pointer to get a greater sum, and now assume that the sum has become greater than the target. So you need to decrease the sum. So to decrease the sum, you have two possible options. Either you can move this pointer backwards, or you can move this pointer backwards. If you will move this pointer backwards, you will notice that this pair of indices you have already considered, so there is no use of moving it backwards. So to reduce the sum, you only have one possible option, that is to move the right pointer one step backwards so that it now points to a smaller number, and so accordingly your sum of these two indices will decrease and it will become closer to the target. So to sum it up, you will take two pointers, and depending upon the sum of the numbers which these two pointers are pointing at, you will move these pointers. If the sum of the numbers these two pointers are pointing at is equal to the target, your problem is solved. If the sum is less than the target, we need to increase the sum. So to increase the sum, we will move the left pointer one step forward so that the value of sum now increases, as this array is sorted in an increasing order, and by moving the left pointer one step forward, it will start pointing at a greater element. And if the sum is greater than the target, we need to decrease the sum. So to decrease the sum, we will move the right pointer one step backward, because as the array is sorted, so the right pointer will now start pointing at a smaller element, so the sum will obviously decrease. So let's see how we can write the code for this. So as you can see, first we have sorted the array using the predefined function arrays.sort, and we have considered the left pointer which is pointing at the first element and the right pointer which is pointing at the last element, and a variable sum. And as mentioned, we need to stop when the left pointer becomes equal to the right pointer. So we have written the condition for the loop as left is less than right, so that we come out of the loop when left becomes equal to right. And now we will get the sum by adding the elements present at the left and the right pointer. And now we will check that if our sum is equal to the given target, then we have found two indices such that their sum is equal to the given target, and then we will just return in the form of an array those two indices, that is left and right. And now we will write for the other two cases, that is if the sum is less than the given target, we need to increase the sum. So to increase the sum, we will move the left pointer one step forward, L plus plus. And the last case, that is sum is greater than the target. So when sum is greater than target, we need to decrease the sum. So to reduce the sum, we will move the right pointer one step backwards. And if we find no such elements, no such indices that their sum is equal to the given target, we will just return an empty array. So let's see what's the time complexity for this. This arrays.sort will take big O of n log n time because it uses quick sort internally. And here we are simply traversing along the array, so it will take linear time. So the time complexity will become big O of n log n plus big O of n, that is big O of n log n, which is obviously much better than big O of n square. So now let's move on to the optimal solution. Consider this array. The target given here is 17, and we also have a container. So what we will do here is we will keep iterating through the array, and for each element we will check that the container contains the required number for that element or not. For example, the required number for 2 is the number required to complete the given sum with one number as 2. So for 2, the required number will be 17 minus 2, which is 15. So 15 is not there in the container. So we will just add 2 to the container, and now we will move one step forward, and now we will do the same thing for 7. We will check whether the required number for 7 is present in the container or not. The required number for 7 is 17 minus 7, which is 10. So 10 is not there in the container, so we will just add 7 to the container. We will do the same thing for 11. The required number for 11 will be 17 minus 11, which is 6. So 6 is not there in the container, so we will just add 11. Now moving on to the next element, we have 15. So the required number for 15 is 17 minus 15, which is 2. So 2 is required by 15 to complete the sum of 17. So 2 is already present in the container. So we have found out a pair of indices such that the sum is equal to the given number. So this is how we will proceed. And to understand why this approach works, you can visualize it as if you are completing a puzzle by joining in two pieces. So for each piece, we will check that whether its completing piece, its complement is present in the given container or not. If not, then we will just add the piece to the container. And why we're adding the piece? Because the required piece for that particular piece to complete the puzzle is not there, but that particular piece, that particular element might be used for some further element in the array to complete its sum. That particular piece might work as the completing piece for some other upcoming piece. So that is why we are continuously adding the elements for which the required number is not present. And in place of this container, we'll be using hash map because we also need to store the indices of the given of the numbers in the array, because we need to return the indices. So let's see how we can write the code for this. So as you can see, we have made a hash map, and the keys in the hash map will be the elements in the array, and the values will be the indices for those elements. And here we are just traversing along the array, and for each element we will check that the required number for that particular element, which is target minus the particular element which we are considering, is present in the hash map or not. If it is present, then we have found out the pair of indices for which the sum will be equal to the given target. So we will just return those indices, that is we will return the index of the element which we are considering currently, that is I, and the index of the required number for that particular element which we are currently considering. since the indices have been stored as values, so I'm using map.get function to retrieve the index of the required number for the element which we are currently considering. And if that element is not present in the hash map, then we will simply add it to the hash map along with its index. So map.put the particular element which we are currently considering along with its index. And if no such pair of indices is found such that their sum is equal to the given target, then we will simply return an empty array. Since we are traversing once through the array, the time complexity will be big O of n. So I hope you understood the solution. If you did, consider liking and subscribing. Thank you so much for watching the video. Bye.